Hello everybody, my name is Arth Acharya, and today I'm explaining you a, a story of a storm actually. So, a storm is a very interesting thing. It's a group of air which is too fast and it turns round and round and round. So, mostly I just don't think I've heard it that people say storms happen because their flow is too big or too small. But no, let me tell you. First, people thought air flowed like this, in a straight line. Then, next people thought air flew like this, in a wavy way. But according to a recent discovery, air flew like this. Now, if you want a proof, I can explain you. Now, imagine this is a friendly neighborhood and you got a tree. This is a tree actually. This is a tree. Here are some waste packets and stuff, leaves and whatever. Air comes in such a fast way that it slowly starts winding up. Now you may be thinking, why didn't it flow forward? It didn't flow forward because the pressure of all that wrappers and stuff didn't let it flow forward. So it will slowly form into a storm. Now this is a moderate storm. It's not effective that much. But if you ask me, if you want to know about an effective storm, the thing happens that this winding up changes the weather. Now when the weather changes, dark black clouds come in. Just imagine this is the storm for a second. Dark black clouds come in. They struck lightning inside the storm. Now the storm was normal, but now it has become severe. So what happens is every storm has a starting point, which is known as the eye. Yeah, it's a very funny way, but it is known as the eye. This is the main starting point from where it starts and from where it moves forward. So this is a storm, it turns forward and keeps moving. Now going on the electric shock, that shock goes inside and that shock reacts with that air, which leads little electricity to the between, which causes it to become severe. Now what's the characteristics about severe storms? This is a normal storm, a moderate, not a big deal. Dust particles flowing, very small. It's not that effective. It's small. It can't pick up a wooden chair, it can pick it up. But if we talk about a severe storm, it is like 10 times the size of the normal storm, which is quite big if you think actually. Now this storm has a more effective pressure on the environment. The clouds become more black than usual, it starts to rain, the water starts rising nearby coasts, and this storm starts picking up even cars, big cars, truck, animals, and whatever things. Now, small parts of debris come inside the storm, and this usually breaks and mixes in with the storm. Now, after the storm, there is another risky storm, which is usually called the final form of a storm. That storm, it can be drawn on the blackboard, so I'm gonna show you a scale. This is a car. I think you understand this is a car. Now this car right here, this is going to be compared to the actual scale. And according to this car, the scale should be approximately starting from here. If this is the eye, this should be the scale of that storm. This big, which means a human will only stand this much moderate size. It's a stickman given example of a human. Now you can see this storm is so big according to this car and this stickman human. So this storm is known as the biggest storm, and I don't know what you call it, but it's a very big storm.
Is it danger?
Yeah, it's very dangerous.
And it can be change your weather also?
Yeah.
How?
It can change the weather.
How?
Like I told you, the air pressure.
How it's possible to change the weather?
It happens when this air, which goes inside this. Now let me show you a quick diagram. This is a sinking air. This tube here is where air sinks, and air outflows from this part. It takes in things from here, and that thing slowly go between, and end up in this tube, which goes out, and then this tornado again picks it up and turns it. Now sometimes this air pressure attracts, like bring electric static powers around it, which means cloud will come near it because clouds have electrostatic powers, and those clouds will start to grumble. Now when this cloud grumble, I told you, it will form a severe storm.
Grumble?
Yeah.
What is the meaning of
grumble? Oh, it's very simple actually. The meaning of grumble is like you have these two clouds. They started to get touched to each other, which forms a lightning spark because of their electrostatic touches. Like, it's a simple example. You have a carpet. It's made of that electrostatic clothing. I don't remember the name right now. Synthetic. Now, when you rub your feet, without gloves or any stuff, you don't
then the spark comes.
Yeah, I mean, I'm saying you should reveal your hands because your toes and your hands are fully connected. They have vessels connected, which even lead electrostatic shocks. So that's why when you rub your feet and then touch someone, then that electrostatic power flows within the body into your finger and attracts to the other person's arm, which attracts to his electrostatic hair or skin parts. Now, just like this electrostatic also touches like the skin from other skin, and it starts making grumble noises. Noises like grrr. And electric currents start flowing down. Now, this is a very good way because if you don't have a battery, you have a synthetic clothing, and you have another piece of anything that is like you can take iron. So what do? You wrap the synthetic in the iron, and then you try to connect it.
Is it possible to do?
Yeah. And I'm gonna tell you another quick thing. It's very cool. I've taken this orange. It's an orange. Wait a second. Now it's understandable it's an orange, right?
Yeah.
So now I insert a coin in here. And I insert a needle. Now the cool thing is you might be thinking, what is going to happen? I'm gonna show you an inside view of this. The thing is, this coin part, actually this needle, because iron, it's made of iron, and iron is attracted to electricity. In the acid, the citric acid in the orange starts to formulate with this iron. When it formulates, it releases a gas which goes towards this coin, but this coin is trapping its way. So this coin's copper or whatever metal, it also brings electricity. So electricity flows in the, what do you call it, orange. Now you may be thinking, how is that possible? It can't flow. Citric acid is actually electrostatic, which rarely people know. Now if I connect a wire to here and a wire to here, and then attach it to a bulb, then it is obvious that bulb will glow because of the electrostatic current. The current will flow into the bulb.
With the orange?
Yeah, it's shocking, right?
Yeah.
The orange produces electricity. You don't have batteries, but you have an orange. You can do that simply, which is quite shocking.
Oh, really?
Yeah.
It's wonderful information.
Yeah, so just like that, it's electrostatic. So where was I? Yeah, on the storm. Now just like that, those grumble and it goes into the storm and it finishes off with a normal storm, which grows into a severe. Thank you. That's all I want to tell you. Goodbye.